Hello everyone, in this video we are going to learn binomial expansions. First thing you need to know is that binomial means an expression including two terms. As you see here, there is a binomial including terms a and b. We are going to learn how to expand this binomial to any power, so generally to the power of n. Now, before learning how to expand, let's consider what we obtained for a few small whole numbers as n. So I start from 0. If n is 0, so a plus b to the power of 0 will be 1. Then I write coefficients here, 1. If n is 1, so it would be a plus b to the power of 1, so it would be a plus b. So coefficient of a first term is 1, I write it here. Coefficient of b is also 1, I write it here. Now let n be 2, so it will be a plus b to the power of 2, which is a squared plus 2ab plus b squared. So coefficients are 1, 2, 1. Just pay attention to the triangles and see if you can find any pattern here. If n is 3, so it would be a plus b to the power of 3. After multiplication and expanding this binomial, you will get a cubed plus 3a squared b plus 3ab squared plus b cubed. Coefficients are 1, 3, 3, 1. As you see here, note the sides of this triangle are just 1. Add these two, it will be 2. These two, 3. These two, 3. So let's see what the next row will be. 1 you have here, 1 you have here. 3 plus 1, it would be 4. 3 plus 3 would be 6. 3 plus 1 also 4. Now expansion of n is equal to 4 as the power, it will be a to the power of 4 plus 4 a to the power of 3b plus 6 a to the power of 2 b2 plus 4ab cubed plus b to the power of 4. Now this triangle in which you can find coefficients of binomial expansion is called Khayyam-Pascal triangle, in which you can find all coefficients. If you continue for any power n, it gives you coefficients. So the terms and their powers, I will tell you in the next part how to find these terms and their powers. So this triangle just gives you the coefficient of these expansions. But the problem actually with this triangle is that, for example, if n is a huge number, if n is a big number, for example, you are going to have expansion of a plus b to the power of 20. So you have to continue till the 20th row for n is equal to 20 to see what coefficients are produced. So it is really time consuming and lengthy. Now, using this triangle, I would like to solve some questions. Example. Expand 3x plus 2 to the power of 3. Now, first, as you saw in the previous triangle, coefficients when n is 3 are 1, 3, 3, and 1. Now, So I write coefficients here, 1, then plus 3, plus 3, then plus 1. Now here we should see how terms are produced. Now I write the first term 3x in brackets, then second term for all 3x 2 in brackets, 3x 2 in brackets, 3x 2 in brackets. Now the first term is 3x, like a in the previous part. It starts from the highest power. Highest power is here 3. It starts from 3, then 2, then 1. Here would be 0. Now second term, it starts, it moves in opposite direction. One of them is written in descending order. The second term is written in ascending order. So it will be 0, then 1, then 2, and up to 3. As you see here, the sum of powers always add up to n. Here is 3. 3 plus 0, 3. 2 plus 1, 3. 1 plus 2, 3. 0 plus 3, again 3. Now simplify. It would be 27x cubed plus, it would be again 27. It would be times 2 actually, then it would be 54 x squared plus 4 times 9, 36x plus 8. Now let's see one more example. Expand 5 minus 2x to the power of 4. Now, coefficients. If you remember, coefficients were 1, 4, 6, 4, 1. You can write the triangle, first row 1, then 1, 1, then here 1, 2, 1, then here it was 1, 3, 3, 1. So if you add them, 3 plus 3, 6, then 3 plus 1, 4, 3 plus 1, 4. So coefficients are 1, 4, 6, 4, and again 1. Now I write the terms. 5, be careful, negative is a part of second term. 5 minus 2x, 5 minus 2x, 5 minus 2x. Now let's go for powers. So in descending order, 3, 2, 1, 0. The second one, 0, 1, 2, 3, and 4. So that they keep producing, adding up to 4. 4 plus 0, 4, 3 plus 1, and it will be the same for the rest. It would be 5 to the power of 4 plus 4 times 2, it would be actually minus 8 times 5 to the power of 3 x. Then here would be minus 2 to the power of 4, it would be plus 24 times 5 squared x squared plus is 3 minus 8, it would be again negative 32 times 5 x cubed, and the last one will be 16x 4. Now it would be 5 to the power of 4, it would be 6 to 5 minus 5 to the power of, it would be 1/1200 plus 25 times 24, which is you can calculate here 24 times 25, 20 times 25 would be 500 plus 4 times 25, which is 100. It would be 600. 600 x squared minus 160 x cubed plus 16 x to the power of 4. Now, what you have seen were actually expansion of binomials using Khayyam-Pascal triangle. Now we are going to, as I told you, the problem with that triangle is that if you want to find expansion of a binomial for when n is a big number, it would be really time consuming because you have to continue row by row to reach the required row. So now in this part we are going to learn a method in which you can directly find coefficients. Now binomial coefficients. Here, before that, you need to have some prerequisite knowledge from statistics that you will completely and deeply learn in statistics. First, factorial. For example, n factorial would be, n factorial means multiplication of n till all the positive integer numbers until 1. So it would be n times n minus 1 times n minus 2, and you continue till 1. For example, if you have 3 factorial, it would be 3 times 2 times 1, giving you an answer of 6. 4 factorial would be 4 times 3 times 2 times 1, which is 24. Now, the next point you need to know is combination. NCR. Or you can write in this form, combination of N and R. There is a key in your calculators. You can directly find combination of N and R, but the formula for expansion of this combination is N factorial over R factorial N minus R factorial. Now, for example, combination of 4 and 2, it will be 4 factorial over R factorial. R here is 2, so it will be 2 factorial. Then 4 minus 2 factorial. It would be 4 factorial, 2 factorial, 2 factorial. It would be 24 over 2 factorial means 2 times 1. 2 times 1, it would be 4. So it will be 6. These are the points you need to know in order to find directly coefficients in binomial expansion. Now, binomial expansion here in this part, without using that Khayyam-Pascal triangle, we are going to directly find coefficients of binomial expansions. A plus b to the power of n will be equal to combination of 0 and n, a to the power of, I told you the first term starts from the highest power in descending order. So the second term starts from the least possible power and in ascending order. The first one descending, the second one ascending. So b to the power of 0 plus combination of 1 and n, a to the power of n minus 1, b to the power of 1. As you see, one of them is decreasing, the other one is increasing. 2n, a to the power of n minus 2, b to the power of 2, and you continue the same pattern until the last term, which is combination of n and n, a to the power of n minus n, which is 0, b to the power of n. And I would like you to pay attention to these points, that the sum of powers in each term will be n plus 0, n minus 1 plus 1 will be again n, and so on, so forth. Now, some points you need to know before going for some examples. First thing is that combination of 0 and n is 1. And the second one, combination of n and n is also 1. Now, let's see an example. Expand here 1 minus, I put it part I, 1 minus 2x to the power of 5. And let me add second part to this question. Then find coefficient of x cubed in the expansion of plus 5x times 1 minus 2x to the power of 5. Let's start with the first part I. Now 1 minus 2x to the power of 5. So I write the first term, second term. So it would be to the power of 5, to the power of 0, combination of 0 and 5. Plus combination of 1 and 5, 1 to the power of 4, minus 2x to the power of 1. Plus combination of 2 and 5, 1 to the power of 3, minus 2x to the power of 2, plus combination of 3, 5, 1 to the power of 4, minus 2x, 5, 0, 4, 1. Here it will be 3, 2, sorry, it will be 2, 3, and plus 4, 5, 1 to the power of 1, minus 2x to the power of 4, plus combination of 5 and 5, 1 to the power of 0, and minus 2x to the power of 5 here. Now let's simplify. Combination of 0 and 5 is 1, so it would be 1, 1, and here is 1, so overall you have 1. Plus here actually it will be minus because of that negative. So combination of 1 and 5 will be 5. So times 2 it will be negative 10x, plus combination of 5 and 2 it would be 5. It would be 5 times 4 divided by 2, which is 10, times 4 will be 40 x squared, plus combination of 5 and 3 will be here 40 if you calculate, 40 times negative 2 to the power of 3, which is negative 8, which is negative 320 x cubed, plus here it would be 16, combination of 5 and 4 will be 1, so plus 16 x to the power of 4, and minus here it would be 32 x to the power of 5. Now let me erase this part to the second part. We don't have enough space here. Now I'm gonna solve the second part. It wants you to find coefficient of x cubed in the expansion of 3 plus 5x times 1 minus 2x to the power of 5. So I write the first binomial times, instead of 1 minus 2x to the power of 5, I replace it by the expansion 1 minus 10x plus 40x squared minus 320 x cubed plus 16 x4 minus 32 x5. Now it wants you to find coefficient of x cubed. You don't need to multiply all term by term to see what what coefficient of x cubed will be. So it is a constant. If you multiply by this term, it will produce x cubed. Here it is x times x squared will give you x cubed. So I multiply just these two pairs. 5x it will be 200 x to the power of 3. So overall minus 120 x cubed plus some other terms that we don't need. So coefficient of x cubed will be minus 120. Now let's see. Example. In the expansion of one plus x over 3 to the power of n, coefficient of x squared is 4. Find n. Now, here, as you see, n is unknown, the power is unknown, so you cannot write the whole expansion for this binomial. But I don't need actually the whole expansion, because the question is saying that coefficient of x squared is 4. I just write the term in which x squared is produced. So you have two terms here, as it is binomial 1 and x over 3. So it says x squared, so here the power must be 2 to produce x squared. So we know that powers add up to n here, so it must be n minus 2 plus 2 becomes then n. So here what we have, combination of n and this power, which is 2. Now, so it would be combination of n and 2, it would be n factorial over n minus 2 factorial. 2 factorial times 1 to any power would be 1, so x squared over 9, which is equal to, now instead of n factorial, I write n times n minus 1 times n minus 2, but I don't continue, I put a factorial here, over n minus 2 factorial, 2 factorial. We can cancel out these 2 times x squared over n. It will be 2 factorial will be 2, so n times n minus 1 over 18 x squared will be the term including x squared. So this coefficient must be 4. So n times n minus 1 over 18, which is the coefficient, must be 4 as given in the question. So n times n minus 1 must be equal to 72. So it will be n squared minus n minus 72, because it leads to a quadratic equation, must be 0. So if we factorize it, it will be n minus 9 times n plus 8 is equal to 0. I forgot to add in the question that n is a positive integer. So n is 9 or negative 8. It is not acceptable because it's negative, so this is the acceptable answer. So n will be 9. Let's see one more example. Given that in the expansion of 2 plus kx to the power of 8, coefficient of x to the power of 5 is twice coefficient of x to the power of 4. Find k. Now, again, there is no need to completely expand this binomial because it's just talking about x to the power of 5 and x to the power of 4. So the term including x to the power of 5, it would be 2 kx to the power of 5. So definitely it is 3 to add up to 8. So combination of 8 and 5. It says it's twice. Now coefficient of x to the power of 4. Coefficient of x to the power of 4 will be 2 kx must be to the power of 4. So it is definitely 4. Then combination of 4 and 8. Now combination of 8 and 5, it would be 8 factorial over 5 factorial. I'm mentally calculating, but you can also use calculator. You're allowed to take calculator with you in A-level examinations. Over 3 factorial, let me write in the 8 minus 5 factorial, 5 factorial, times 2 to the power of 3, 8, times k to the power of 5, x to the power of 5 is equal to 2. Combination of 8 and 4 would be 8 factorial, 4 factorial, 4 factorial times 16, k4, x4. Now 8 factorial and 5 factorial, you can cut out after 5 factorial, so it would be 8 times 7 times 6 over 3 factorial will be 3 times 2 times 1, which is 6. 5 factorial will be cancel out with 5, 4, 3, 2, 1, which should be written after 6 times 8 k5 x5 is equal to 8 factorial, and 4 factorial will be 8, 7, 6, 5 over 4 factorial will be 24 here times 2 times 16 k4 x to the power of 4. Now let's simplify here. 6 and 6 cancel out. You can cancel 8 from both sides. You can cancel 7 from both sides. You can simplify this 8 with this, which is 2. Then these 2, which are 4, it will be 6. Then these are cancelled out. So what we have is k5 x5 is equal to, on the right hand side we have 5 k4 x4. Now I transfer whatever I have in the other side and factor k4 will be common factor, x4 will be also common factor. It will be kx. Actually it is talking about coefficients, so there is no need to write x to the power of 4 and x to the power of 5 because it's a matter of coefficients. I erase them. So k to the power of 4, I transfer to the other side. It would be k to the power of 4, k minus, I remove x, k minus 5 is equal to 0. Once k will be 0, which is not acceptable because it doesn't become the binomial, so k will be 5 as the answer. Now see another example in this regard. Example, find the term independent of x in expansion of x plus 5 over x squared to the power of 9. Now, these types of questions are really common in A-level examinations. Now, you have two terms. I write the two terms now, and the combination before. It says independent of x. It means that there should be no x in this term. So we know that powers add up to 9. So I should choose powers so that they add up to 9, and this term here will cancel out each other. If I put 1 and 8, it won't happen. 2 and 7, it won't happen. 3 and 6, it won't happen. 4 and 5 won't happen. Then 5 and 4 won't happen, but 6 and 3. It will be x to the power of 6, and here in denominator will be x to the power of 6 using power on power law. Then they cancel out each other. Now what is placed here? 9 and 3. So it will be combination of 9, 3, x to the power of 6 times 5 to the power of 3 over x to the power of 6. They cancel out each other. So the final answer will be 10,500. So this video was about binomial expansion. I hope you all understand what is taught in this video. Thanks for watching this video.